Okay, so what we covered today? It will be the architecture of internet in a nutshell. So how it's organized in a big scale. What is web in different generations, and the basics of crawling. Not those which you showed in the previous class, but the like an etiquette of crawling and the ways how to behave. So let's go. Can you tell me what's internet? Maybe you.
Internet is a combination of different networks.
Combination of different networks. Okay. What is network?
Network is a combination of different
People.
different
Sites. So combination of people, sites, and they combine the networks, and they together combine into internet. Nice explanation. It's actually covers what is called Web 4.0. But if to go in very, very deep basics, it's a combination of machines and the internet protocol to deliver data between these machines, among these machines. Yeah. So you have like your smartphone, this tablet, this laptop. They are now transferring the data. So the screen, which is showed here, is copied here. So there is some traffic going through some servers to get this picture from this computer to this computer. Okay, so that's what internet is actually doing. The purpose of any network here is to deliver data. Everything else is upon this. So what you need to do, transfer some data. Okay, the basics of internet is what is called IP protocol. So there's IP, internet protocol. The task of this protocol is to show how to lead the data through the network, and to, if you want to transfer the data from this machine to another, internet protocol is the friend which takes your data at the hand and leads through all the nodes, routers, and network sections in the internet. Internet protocol is defining the fact that there are numbers assigned to machines. Okay, these are your addresses. Like you live in some buildings, you have address which identify the location. It gives you the correct exact identity of the place. It doesn't give you the way how to achieve the place, because like saying that you live in Innopolis on the like, Sportivная street, for example, doesn't say how to get there. Yeah, but it gives you an identity. And the protocol of, I don't know, Russian Post is actually the like internet protocol. They know how to use this data to get to this address. The same comes here. So the number which is assigned to your machine for 4 numbers, 4 bytes, is internet protocol version 4, which is assigned to a machine. And this number can be represented in multiple ways. So here, these 3 numbers on the slide actually representing the same machine. So these are 4 numbers in a decimal notation. Yes, this is hexadecimal notation of the same number. So C0 is 192, 33 is 22, 3D is 61. So these are just another way of writing. And if you open this website, I don't know will it will work here like this. So if you, oh, it was not what I meant to do, but if you copy this link, so for example, this address, it will lead your, for example, browser. Oh, sorry, HTTP. So I will add protocol, and I will speak about protocols later. To the machine. So you see, it changed the address to the decimal notation because it's more convenient for human. But this is exactly the same address, another way of drawing this. So you should understand that IP address is just what? Four numbers, 4 bytes. And we will speak about this later, that this can be a tool for manipulating humans. One of the most widely used ways of creating phishing links in your emails is based on the fact that you don't actually know what is a server in the internet. And here is an example. Here, I think I can draw it here. Example of an email which a typical user will understand, like, so a URL in email, which I can put, will understand as the one which leads me to a website, medusa.io. But actually, it will lead me to this machine represented by this that small number, which is actually this server. Okay, so you understand this is like the fooling of the human. So you can think that this is the name of the domain, but actually this is domain and this is username. And we will speak about how the URL is organized. And for example, we can you can do a simple like small lab by yourself. You have laptops. You can try in parallel to do what? Obtain an address of, let's say, Mail.ru website. I think that one is Mail.ru website IP. Convert it to a hexadecimal representation, for example, with this website. This is a link. And add whatever column add sign, and you will create an URL which will lead you to this server, but it looks like it leads you to whatever. Okay, so it's like the way of fooling. So this is what you should know about the IP address. IP address is just a set of numbers, and you should be very careful when you see numbers in URLs. There are a few things which you should know about the fact that some IP addresses, some numbers for machines are reserved. You know that there's a loopback 127.0.0.1, which leads to your particular machine. There are some other predefined ranges of addresses, like, for example, 192, 168 something is usually the local area network addresses. So they are somewhere in the building usually. Yeah, and so, some other ranges which are predefined, but others are like can be public. And what is interesting that we usually think about public IP addresses as about something static, but there is an organization called ICANN, Internet Corporation of Assigned Names and Numbers, which manages internet. The task of this corporation is to assign names, domain names, and numbers, IP addresses. And first of all, this organization says that IPv4 is over, so there are no more spare IPv4 addresses. So now we need, like, the whole world should switch to IPv6, which is longer, 128 bits for an address, another protocol. And second, there was a case with a company called Parallels, which I worked for, when they were using the same IP address for like report collection for lots of years, like 20 years. And at the moment when the range of IP addresses became smaller and smaller, available addresses became smaller, ICANN retracted this IP address from the company. So unfortunately, we will take this IP address from you in a year. You need to prepare your environment for doing this. And just imagine this IP address was hard-coded in the software, because like you need somewhere to put somewhere the number where to send your reports. And they were thinking that maybe the name of the company will change, but IP address will definitely be ours because we paid for like 100 of years ahead. And this organization said that unfortunately, no. So this IP address will be ours, and you will need to like change, find another. And the company was creating some kind of these fixes to just be able to collect reports in the year. So IP address can change. This is an important outcome from this slide. Okay, what I said in the previous slide was actually lies. IP doesn't equal machine. So as I mentioned, the number of IP addresses is fixed. You can even pre-compute it. So it's like 4 bytes. So how many machines can you express with 4 bytes? 4 bytes is actually what? It's an integer value. It means that 4 billion of numbers, and that's all. That means that sometimes you have to deal with some tricks. One of these tricks is, for example, network address translation. You have your own network, you have your router in your home, and like 3 machines in your home. And for anyone in public, your traffic looks like it goes from the router. So it has the IP address, but whatever machines are behind the router, they are invisible. They are just different ports in your router. So everyone from the outside will think about your infrastructure as about single machine, and your actual like request addresses will be like this, but your machine address, which it knows, will be like this. And there is the translation table, for example, which exists on the router, which says that we will convert it on the fly. We will exchange the IP address, and you don't have a public IP. You just have something which is only local. Again, so we will be moving fastly. So if I, for example, click this, this is the service which says my IP address, okay? And it says for outer server, my request came from this machine, okay? So we can see that it's 188 something. Okay, wonderful. Let's switch to the slides. Not slides, slides are here. And if I do it like this, so I will do the experiment. Which you prefer, Windows or Linux? Which is more common in your environment, Windows or Linux? What?
Linux.
Linux?
Linux.
Linux, wonderful. So Linux online, Linux. Okay, so I have Bash here in Windows. I'm tricking you, but you know that there is a Linux subsystem in Windows. So if I print this line ipconfig ifconfig, this is the tool which shows my like interfaces, and I'm grabbing this result with inet. So I will be looking for inet.
You can see the timeline.
Oh, sorry, only I can see it. So this is the result. You see that I have, first of all, multiple interfaces. So this one is 172 something. This is some local network. I have IPv6 address. This is a loopback. So it's the address of my machine. And this is, again, loopback for IPv6. And this is my, like usually when address starts with 10, it means that it's a corporate network. So it's like a university network. And there is no 188. Yeah, so that my machine doesn't know that for the other world, it looks like another IP address. So this is what's important. You should understand that IP address is a tricky thing. So it's different for your machine and for everyone who perceives it from the outside. Still, there is an interesting thing which is important in terms of information retrieval. When ICANN assigns ranges of IP addresses, it usually gives a range to some company which will be later distributing these addresses among the users. So for example, there is a Rostelecom provider in Russia which is owning some addresses. It gives the sub-ranges to other companies which are smaller, and then you come to Tat Telecom and you just want your own internet in your home, and your IP address will be from the range of the bigger, smaller, and so on. That means that usually IP addresses are somehow mapped to geography. So with some accuracy, so you see that 99% for country and 95% for city, it will identify your location. So IP address identifies your location just because the schema of assignment of IP addresses is done like this. So you give a range of addresses. You know that this range went to Russia. So now you know that this IP from this range will be Russian. Then it is given to Voronezh, and now Voronezh is distributed and that's like this. And this is an interesting thing because using IP address information, just IP address information from where request came, you can, for example, switch on the interface in your website, saying that it will be in English or in Russian. You can compute some things related to users. So if you want to collect the data, you know IP addresses of users, you can at least as a feature compute the location of the user. Is it Russian user, Czech user, I don't know, American user, and so on. Of course, you need the database, and you can achieve it for money, like you get it for money, or you can find some free databases. But again, as I mentioned in the previous slide, IP is tricky, and usually you see only the last public step in the chain of calls. That means that such techniques as network address translation, using web proxies, turbo mode in your browser will fool the server. They think that you came from Ireland, but you actually sitting here in Russia. Okay, and that can be another problem for obtaining the good current geographical information. Important thing about the internet, just how it's organized. There is the division of internet into tiers. Like the tier 1 operators are the biggest operators in the world. The major of the world are AT&T, Orange, and so on. In Russia, we don't have such operators. Why? You can listen, like if you know Russian, there's a good podcast in Russian. Sorry if I don't know such a podcast in English, but which explains the situation like with this in details for half an hour. But still, the task of tier 1 providers is to create the infrastructure of internet, and their main feature that they have the points of exchange between the networks, and this exchange comes for free. So there's like AT&T and Orange, for example, they cover the United States, and whatever is delivered by AT&T, whatever is delivered by Orange, if you want to transfer the data between these two networks, the point of exchange will be working for free. So they don't pay each other. They just one send traffic to another and vice versa. Altogether, they are called, sometimes you can see the word backbone of internet. So they create the skeleton. Tier 1 operators, sometimes they are partially paying for the data, sometimes they don't. But you understand that all they solve the problem of, I want to send a request from Russia to Ireland. And there will be like a chain of providers who will be like bringing my data through the network. Rostelecom finishes, now another operator comes in Europe. Then it finishes, another comes. So the traffic goes through multiple operators, and it would be nice if they don't pay each other, because like billing will be awful. Like you can imagine how many requests we are doing in the world. So tier 1 to tier 2 operators, they again, like they are, for example, you can say about Rostelecom or MTS, Russian providers, as about tier 2 operators. In Russia, they are usually called tier 1, but this is like, here's the star, meaning that in the world, they're not recognized as tier 1 operators. And then there is the tier 3 operator, which only pay for access. So they are right here. Yeah, so they are buying traffic from the big brothers, and they sell this traffic to you. So whatever you pay for internet, you pay to tier 3 providers like Tat Telecom here in Innopolis. So what are interesting outcomes from this? First of all, local operators like Tat Telecom, like Rostelecom, they are subjects of national regulations. If they are local, that means that there can be Roskomnadzor or any other organization which manages internet, which can block some ranges of IPs and can manage the traffic. You, in this podcast that discussed, maybe you observed the situation when there's a national provider in Belarus, in the neighboring country, which is the only operator in the country, and they just switched off the internet because they could, by the government order. And it was possible because they are local. Yeah. Still, this is the situation which is unusual, because usually country has multiple tier 2 providers, and that means that they usually have the multiple points of exchange with multiple tier 1 providers. So if one switches off the internet, you can use another. That's why like the backup channels, which allows you to build like VPN networks and so on, they can be important for keeping the quality of your service, for example, or just be sure that you send your traffic through different networks to know that if one will switch off the internet for you, the other will be working. I know that poker players are usually doing this. So if you play online poker, it's very important not to lose a table. And if your internet connection is not stable, it's better to have two cables plugged in your machine to be sure that internet is working. So that's what I observed from my friends. What else? If someone can manage the internet in your country, think twice about where you will rent, attach, or build your data center. That's very important. So if you want to run your service somewhere, think about, will it be possible for any national government to switch it off, for example. You know now that small networks are sharing the same IP address for others, and it means that, for example, if someone is misbehaving for like in Innopolis University building, what you sometimes see when you open Google, it says that please check that you're not a robot. So someone is misbehaving, but because of the fact that you share the IP with this person, for example, the person is trying to attack some website, the Google is thinking that you're maybe also misbehaving. So it asks you, even if someone else is doing bad things. And also IPv4 is over, which I also mentioned. And yeah, I said about traffic exchange. It's called IXP, Internet Exchange Points. The places where these providers are exchanging the data. Usually this is not a pair of providers, but a bunch of providers. For example, in Moscow Hub, there are 500 organizations which exchange the traffic in the same building. It's one of the biggest exchange points in the world. Okay, so this is, for example, the network of Rostelecom. So just from their map. Of course, not all of this belongs to the Rostelecom. It's strange that in China, Rostelecom, but there is infrastructure which Rostelecom uses to provide internet in Russia. Okay, a small example of what I showed you about tiers. It is unfortunately, this is a slide of last year because today it's not working. The example was the following. So I was tracing my requests to the same website called RootRacker.org. It's a website which is prohibited in Russia, so you cannot use it. Actually, you can, but you need to do some tricks. And I did the request from the same machine. You see that like the same command line, but using two different ways. First, I used internal internet channel of Innopolis University, which was at that time given by Rostelecom. It's the biggest Russian company. And the second was through Megaphone, from mobile internet, through 4G internet. And what I got, that Megaphone is actually performing well. It blocks my access to the website, and it doesn't give me the website. Yeah, so it was they work for Roskomnadzor exactly by the order. But Rostelecom is the biggest provider in Russia. They didn't care for some time. Now they care, but a year ago they didn't care. And I was able to just from this building access LinkedIn, RootRacker, whatever is prohibited in Russia was available from this building. And this was because I used different tier 2 providers, like the big providers here. So one was sending traffic without filtering, another with filtering, and from the same building, from the same machine, could achieve two different results by accessing the same website. Okay, let's go further. Again, you can try, and you can combine your knowledge from the previous slides to, for example, answer the following question. You have a service somewhere. You want to see which machines belong to your region, which machines belong to other regions. So knowing IP addresses, you know that using some geo-coding techniques, you can understand the location. So we can track how your actual signal goes through the world. Okay, so this can be an important task to know about your services. You provide some service, how users obtain the information from you, which channels they use, which tier 2 providers. There's also the service like Whois. I think you all heard about such services. For example, Russian Whois for Regru. They can, if you type some IP address, I don't know, this one, for example, they can show you the owner. So they can say that this IP address belongs to Rostelecom. They can say where is the address of the legal entity which owns this. For example, it shows it's Moscow, and some other information. For example, for how much time. Usually this information is here, last modified. So, you can even call them. There's a phone number. Well, usually there should be a lease time, last modified. No, so there's no such information, but sometimes there's information about how long it will be belonging to the same organization in future. Okay, next thing. So we're we should be moving fastly. We were speaking about numbers, and I was showing some examples with domain names. What's the difference? There is another infrastructure on the internet, which is called domain name system, DNS, which is created for humans. So machines are okay with dealing with numbers. So these 4 bytes are okay to address another service. So if you can remember these 4 numbers, you can go somewhere and retrieve the service from there. But what about humans? Humans are not very good in remembering such numbers. That's why the domain name system is created to make us remember websites names. Of course, for now, the way how you act in the internet is actually slightly different to what was 20 years ago. You don't usually remember website names. You go to like Google, you type the name of organization, it will return the website. But previously, it was very important to remember a website, where you go every day. And again, there is an infrastructure of 13 core root servers, which are named like this, and they are responsible for the whole internet. This system is not just for humans, but also for the thing that you can now make a level of abstraction, and you can say that behind this name, behind this domain name, there is not a single machine, but a variety of machines. And the way how they work will be different for different users from different countries, for example. Just a simple example of Yandex. I think you can see it here. Yeah, so I have 2 machines. This machine is located in New York. Okay, and what I do, I'm just pinging, I'm sending a request to Yandex.ru. Okay, and what it says that the address of machine is 7788 something. Okay, so it's some machine somewhere with this number. Okay, if I do the same from my local machine, so here it was my personal laptop, and I'm doing the same, what's here? The IP address is completely different. It's 213 something, so the yellow here. It means that the same website with the same name, just because DNS allows this, is multiple machines. Actually, like for Yandex, I know it from internals. There are 3 data centers. 2 of them are serving Russia requests. Like, for example, from here, I will be most probably leading to Vladimir region. But for external requests from out of Russia, there is a Finland data center, which serves requests from outside. And I achieve, like, I get the same service from different machines by the same domain name. So domain names are allowing us to have, like, if IP addresses allows multiple machines have the same IP address, domain names allow multiple machines have the same domain name, and even multiple networks have the same domain name, and vice versa. If I try this, so let me first of all, yeah. So if I try this, so so if NSLOOKUP is actually the tool to use DNS like from the command line. So if I write NSLOOKUP for my website, what I will see this IP address. Okay, wonderful. You maybe saw it before. But if I do the same for another website, you'll be surprised. It has the same IP address. So another thing, that the same machine can have multiple domain names. Yeah. So internet is not just a simple thing. It's not that there is a machine, there's a name for a machine, and we just crawl it. There are multiple machines grouped in the networks, which are hidden behind the IP address. And this IP address can be one of multiple which are behind the domain name, but also there can be multiple domain names sitting on the single machine. This situation is very, very common when you, for example, deal with VPS, virtual providers, so which are giving you not a dedicated machine, but a virtual machine inside the data center, and then you can build your website there. And they just say that we don't care about your, I don't know, computational powers. You just need a single page website. So there will be like 100 of them running on the same machine. and they will be just sharing the same IP address. Okay, and there will be different domain names, and each time you come with a request to this machine, it will by some means identify which of the virtual machines will solve the request. Yeah, the question. This is a single machine. This is yeah, this is my machine in New York. Yeah. Okay, so in this case, this is a single machine, not a network. Yeah. So as I mentioned, there are 13 root servers in internet. 9 of them never changed their IP address. That's why it's still possible for the whole internet to function. There are other alternative DNS services. You know that for Google, there is like 4 8s, like 8, 8, 8, 8. This is the DNS from Google, which is alternative to the DNS from the whole internet. You can use it, but you understand that it means that people who use different domain name infrastructures will probably get different services for different names. It can be the case. Okay, the thing which manages the domain names mapping from domain names to IPs is called resource record. And if you have the machine, in my case, it's DigitalOcean, so it's a provider who gives me the virtual machine. I here specify which low-level domain name services will be dealing with my machine. So that just to know that this is managed at your provider's side. So which machines will be resolving your names. Because when you go to the top level, so let's say spartasov.ru, sp.ru. So first, root means I will go for one of these 13 root machines, and it will then address me to another machine, which will be responsible for Spartasov. Yeah, and then it will send to the local machine of this ns3.digitalocean.com, which will say which IP address is assigned to my machine. So it's like a tree of machines. Short quiz, like few questions about your understanding of what's going on right now. So I understand that you're lost a lot of information already. So the question, they have a website, it opens for me. Another doesn't open. The same happening to my colleague in the office. What can be the reason? Same provider, of course. Like it's obvious thing that yes, if behavior is similar, most probably you're using the same provider. But why the website which should be opening is not opening? Because of multiple reasons. There's the chain of machines and network segments which are between you and this service. And what can go wrong? The machine which is representing that service is off. Okay, so it's not working. Second, something happened to resource record. So this domain name is no more assigned to this IP address. So the release of domain name finished. And sometimes you can see, like if you open website, it shows like domain name is parked. So you can buy it for this number. So someone bought a domain name for like 1,000 rubles for a year and didn't pay second time in a year. And this domain name became public, so you can buy it now. So, and this can be the case. Any cut in the network because of technical reasons, Roskomnadzor, any authorities which manage your internet, can be the reason of why you cannot access this. But it means that internet is working, but something went wrong with this particular service. Yeah. Another situation, something works for me, but doesn't work for my neighbor or vice versa. So what can be the reason? Parental control. Great. So you have different setups at your local machine. What else? Different providers. Yeah, obvious. So you might have Megaphone, you have Beeline, and they are just managing internet in a different way. What else? Different local networks. So something went wrong in the network, but internet is working. So yeah, so the networks and then the providers again, the different. And so multiple reasons again, but this is the most probably the idea that if in the first case the infrastructure is the same, the problem on the side of the service. Here, the infrastructure is different. Yeah, so something went wrong in your setups. And if the service is available for your neighbor, it means that something wrong with you. Yeah, with your personal workspace, with your local network, and so on. So first, here you should blame the owners of the service. Here you should blame IT guys from university. That's what usually happens. The question which we will answer in the next lecture, but maybe you can provide me the idea. You were crawling some marketplace, so you're obtaining the data from some marketplace by running requests from request slip. It worked for 2 days, and on the third day it stopped working. What can go wrong? It can be blocked by a website. So they saw that there is traffic coming from a particular machine, and they blocked this IP for obtaining some part of requests. And actually, what happens when someone misbehaves in university? You see that Google lists our IP address as misbehaving and asks you to verify you're not a robot. Okay. And one more thing, I clicked a link which starts from Google.com, and it shows that my connection is not secure. But I know that Google secures all the connections. So what can go wrong? But Google will redirect you. Just if it's Google, it will from HTTP request will redirect you right to HTTPS. There are no websites from Google with no HTTPS. Yeah, definitely. It can be at and colon here that someone is using a phishing technique to lead you to another website. Yeah. Emilia, did you want to say anything else different?
Yeah, I said man in the middle attack.
Yeah, man in the middle. So there is also a chance that there is the network infrastructure, which is actually capturing your traffic and resends the requests, but they don't own the certificate. That's why what they can only do, they can build an unsecure connection to you. So they substituted Google.com, and they're capturing these requests and resending you answers from that website. Yeah, but definitely this case, you see that in the background, this is the part of my website. So it means that actually I built the phishing one. So the answer for this particular question was, yeah, with the phishing technique. Great. Before we continue, few takeaways. So first, internet and internet protocol. IP manages how data travels in the network of machines and smartphones and whatever. There are providers which are traveling this data through the world. Tools which you can use here and which are showed in the slides, they are TracerT, which shows the sequence of machines from your machine to some other. There's ping, which shows that machine is answering, it's alive. And ipconfig or ifconfig in Linux, which shows that which interfaces do you have at your machine. And you will see that so no public interfaces. There is the protocol TCP, which is upon IP, and you know this pair TCP/IP, which says how to transfer the data, preserving the integrity. So just a single block of information is small enough. So you cannot send the arbitrary big sequence of data. The internet sends the data by blocks, and if you want to send a big web file like a movie, you need to split it into parts. And TCP cares about gluing it back, even if these parts traveled in a different direction. So if part of them traveled from megaphone networks, part of them through Rostelecom, if they reached the final state, it will glue it back. Okay, and these tools like NC and Telnet, and we will try them, are using on the level of TCP. So they allow you to just like in a raw way to use TCP protocol to address to some remote machine. DNS manages string names for IP addresses. It creates an abstraction which allows you to hide multiple machines behind the single domain name. It allows you to run multiple domain names on a single machine to reuse your resources, which is good. And tools which you can use to access this service are NSLookup. and ping. Ping is like just it resolves the name like implicitly for you. Okay, we have 30 minutes of this class left, so let's continue. I have a lot of things to say. If there are no more questions, if there are questions, you can raise your hand. No questions. Wonderful. Few words about the next level. So we know how data is traveling in the internet. So what is actually what we use here in this course and when we use internet actually? We use not the raw infrastructure. We use what is called World Wide Web or just web. This is the graph of documents which is mapped to this infrastructure. Yes, these documents are placed on some servers. So servers are machines. But these servers are not physical servers like you can understand this device, but a service like a software running on this machine. Okay, that means that, as I mentioned, like there is a physical machine which owns two my websites. There are two web servers. Yeah, so at the same physical machine, they have different documents which are indexed and which can be attributed as different documents from different servers. So this is an abstraction level. Hypertext, what is mentioned here is a concept which is very ancient. So hypertext can be mentioned like it's a dictionary. So dictionary sometimes refers to other articles in the dictionary, saying that this la 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 la, look at the article this. Yeah, I'll go to this paragraph. So it links you to other content. There's a way of linking other content, and this is called hypertext. Text with references to other texts. So dictionary, like or encyclopedia, is a typical form of hypertext. In the web, this is mostly done with the language called HTML, hypertext markup language. So the hypertext, so links among the documents. So you go to website, like to the search engine, you search for something, creates you a snippet, and there's the link. You click the link, it links you to another service, which gives you the document. There is another link, it links you to another document, and this is how you travel the internet. So this is how you dive into Wikipedia. You travel from one page of Wikipedia to another, and then you understand that it's 2 a.m. and you don't know what was the question in the origin. So HTML is a standard, like it's so the status quo for everyone to represent the hypertext in the web. There are some generations of web. So web 1.0 was just the collection of such pages which were stored at some machines, and these pages linked each other manually. So people wrote these links by hands, and like everyone knew all the machines in the internet. Like there were around 100 websites in Russia, and everyone like knew the owners of these websites. And there was the person Artemy Lebedev. Maybe you know this is a Russian famous designer, and he was the one who created the site with the collection of such links of all Russian internet. So you can go to his website and find like all services which are actually exist, which exist in the world. Now it's impossible. Do you understand the number of services is enormous? And the second step was Web 2.0. Everything which was beyond static documents, like social networks, blogs, which appeared to be dynamic and which required some applications behind these web pages. Okay, so it means that if a static web page is just a text file, which you can save at your machine, when you speak about web application, it means that you go somewhere by a link, and it creates a page for you, like by request. And it can be different for different people. If previously it was just a single page for everyone, now this is the personalized thing. So if you go to vk.com or facebook.com, the page for me and page for you will be different. Yeah, you understand? Great. And this became the era of services. Yeah, so the different services appeared. They started doing software delivered through the browser. Web 3.0 is like the term which is usually referring to semantic web, and it was important to understand that when search engines became like very popular, and the way how you access internet, like through social network or through search engine, like there are no other ways. You open the browser and you type something in this line, and what you do, you access the search engine. Sometimes it can just replace it with the like website and it lead you to a website. But in other cases, it will search for you. Or if you open Facebook, if you want to access some content, what you do, you scroll the ribbon of your Facebook, and there are some beautiful snippets of some websites. You can read it from the Facebook, or you can go to the website. But to prepare such a snippet, like a beautiful picture together with a small abstract, with like everything aligned beautifully, Facebook should understand how to present your data of your website at Facebook. And for this, you need some special markup inside your HTML document. Instead of just writing some text and putting some images, you should add some specific meta tags to your HTML, which specify that this will be the like preview in social network. This will be an abstract. This will be a date of event. This will be a contact phone. If you, for example, type in the search engine and you find, I don't know, I think, show it here. It will be in Russian, but I know that it will work. I need Yandex, I think. Yandex.ru. So you see here, this is the website. This is the commercial. And where's the website of my wife's father? Let me find it. It was firstly, yeah, this one. You see here, there are some, where's the phone? There's phone previously here. And anyway, so just let's see some examples here. There should appear somewhere the documents which are well prepared for web. I don't know. Let's use another example. What kind of service you like? So like food delivery. Yeah. So see here. Here is the service. Yeah, Еда Yandex.ru, which delivers food, and it not only gives you a snippet, it also gives you a special prepared links for different cities. It gives you a location on the map. It gives you a phone number, which you can click from the browser and call from your smartphone. So what does it mean? That they paid some time and some efforts to integrate some meta information in their website. And again, Delivery Club, again, the same. There is address here. Or any other services, for example, here, yeah? With some address here, not that beautiful, but still. And the good website will put a lot of effort to preparing the data for representing in soft social networks, in search engines, and so on, to be accessible right from the website. Because what happens if you want to tune the piano in my hometown, you will search for it in Yandex, and if you see a phone number right in the answer of your search engine, you will click it and you will call it from your smartphone. And no even crawling to the website, no accessing the website, you just call the person from the search engine result. Okay, and this is why we need semantic web. So semantic means that there is some work done to prepare websites to be readable by machines, not humans, but machines. So this is invisible for humans, but machines can create some benefit from it. Okay. Together with this evolution of semantics of the web, the language itself evolutioned. So first it was SGML language, so it's standard generalized markup language, which was used in the Web 1.0. It was the first standard, and HTML was like an implementation of this standard. Later, when social networks appeared and everything, when things came to displayed interactive content, HTML evolved because it needed new tools to display videos, flash animation, and so on, so on, so on, so on. So language evolved, and also it fused together with another standard called XML, which is extensible markup language. You know about XML. XML is another, like they're very similar when you look at them, but HTML is a set of tags which are predefined. So they say that you can write this text, and this will be bold, this will be italics, this will be a header, this will be something, and there are tags for this. XML doesn't limit you in terms of which tags you can use. So it allows you to write any tag if you define the semantics for it in a schema document. So XML is a way of persisting some structured information for business needs, for example. Some configuration files using XML, web services which create like the remote communication of machines use XML, and so on. And the fusion was that HTML is a language which is usually misused. So the way how web designers in the past used HTML was that they usually do a lot of mistakes in the documents, and that's why web browsers needed to fix these mistakes on the fly. XML is a very strict language which disallow you to make mistakes. So if it's not written well, the document will not open, it will not compile. Yeah, and when you bring this strictness to HTML, this allows what? Allows machines to parse HTML documents. So previously, only browsers were special software who could parse a page because they used all these sticks and ropes to make it render. But if you say, I will bring the strictness of XML into HTML to create XHTML, now I can make machine read this document also, any machine. And later, with a standard HTML5, what happened? So the same strictness, together with some new features. New features appeared, but now we only guarantee that the document XML parsable. And since Web 2, and for now, XML parsers are useful tools for parsing HTML documents. So before, in the era of Web 1.0, it was impossible to use XML parser here because it was not the same language. And there is also Web 4, and this is the comment for your definition of internet. There is the term which you can see, Web 4, sometimes referred to the next step of internet, where the network will connect not only machines, but also like humans, animals, artificial intelligence, and so on. So imagine your dog has a tag which identifies this dog, and this dog is connected to the network, and it allows you to track the location of the dog. So it's now the part of the network also. And also, it's like as a possible way, it also allows neural communication. So we'll not only be using devices, but we'll also connect our brain to the internet directly. Just imagine it will happen by the proposals of ideologists of this in 2 decades, for example. Just you will be young and still this will appear in your life. I see that there is something happening in the chat. Heavy traffic. Oh yeah, there were sorry, there were answers for the questions, so I didn't open the chat window. Okay, let's go further. One more important thing about the web, how you retrieve the document. So we are doing information retrieval, so let's speak about retrieval, the basic thing. These 3 terms are sometimes misused and confused, and you should understand them exactly. So first, uniform resource identifier is what? Is an identifier. You can find in your programming languages the classes like URI, which manages this kind of strings. So this is the machine readable text identifier, which identifies a resource. So URI is something which consists of 2 parts, very simple. There's a scheme and some scheme specific part. So scheme says which, let's say, protocol, which approach we should use to work with this document, okay? And the scheme specific part gives an identifier of the document. There are 2 types of URI. So URI is an abstraction. There are 2 types which are usually used. One, which you all know, is called URL, Uniform Resource Locator. Locator gives us an important idea that using the information in a scheme specific part, in this part. Using this, you can find a resource. So not just identify it, but also somehow find it. So how it will work for this URL? So HTTP says we will be using hypertext transfer protocol to get the document. When we speak about HTTP, we know we should start the following protocol of actions. First, we will extract the name of a domain where the document exists. Yeah. What next? We have a domain name. Then we go to a domain name service, and we obtain the IP address for this machine. Then using IP protocol, we find this machine. Yes, we find the location of this machine, and by instructions given to us by a schema, we will work with this machine by this protocol expressed here. So we will send the request in this language, let's say, and this machine will answer us in this language. If the protocol is different, machine cannot understand us. So schema says how to behave. The other part says where to go. So DNS first, IP protocol next. Sometimes this can be a different URI. So URN, Uniform Resource Name. So name means there's no location. So you just identify something, but this something is not giving us any glance of how to find the document. For example, ISBN, you know what's ISBN? International Standardized Book Number. It's the number of a book. Any book which is published is given this number. So this is the identifier of exact book, not the instance, but the whole publication. So the same book, it has this. But and as there are multiple such books, you cannot say how to find this one. So this number doesn't give you an answer. But knowing this, you can go to the library or to the bookstore, and ask, do you have this book? And they will say yes or no, because they also know this number. Because you can forget the name of the author, you can forget the name of the book, or you can make a mistake in the name of the book, just in a single letter, and it will be impossible to obtain the book. But using this number, you can make no mistake. Another important type of URN is unified, is a magnet link. Do you know what's magnet link? Have you ever used it? Yeah. Yeah. When you want to download a torrent in a BitTorrent network, you have two options. You have the torrent file .torrent or magnet link, which looks like this. And it's an interesting thing. Nastya can say a lot of things about this. There is the overlay network. So you have an internet infrastructure, and there are actors in the BitTorrent network, like your peers, like your machine and other machines. And by the data structure called DHT, distributed hash table, by using this is actually what? A hash of your document, hash sum, so just a small identifier of the document. You can use the distributed hash table data structure to find the document. So this is a number, just a hash of your document. But this protocol, Magnet, says that if you have a particular software, like you have a browser for web pages, you have the torrent client for magnet links. If your client knows how to use BitTorrent protocol using DHT, they can retrieve this document from your peers. That's a cool thing which can be done with the BitTorrent protocol. So this is both, you see, it's URN, yeah. But it also, with a specific software, gives you a chance to retrieve the document, but no one guarantees it. Okay. So we have some time left. So URL syntax. For those who don't know, just an important set of knowledge. So everything starts with what you already know, with a host name. So the machine name. It can be just an IP address here, or it can be a domain name. So both are acceptable here. And this thing says the location, where to go, where is the machine, okay? Next thing is going after a column, and this is called a port. Port is a numerical value, which is actually a simple idea. A machine is something which can be a multitasking thing. Yeah. So multiple clients, multiple services allow you to run multiple requests to multiple services at the same machine. Yeah. Why not? So, for example, there's a mail server in Innopolis University. There is the web server of Innopolis University. They have maybe the same web, like the same domain name, but they should be somehow distinguished. So how would you know? Did you went for email or did you went for a new HTML page? So there's something which should help you to distinguish which service at this particular machine you want to address. And port helps you to select this. What is important about ports? There is a set of predefined, like, again, this is not a standard in terms of this is the law of internet, but there is a convention which says that there are some specific ports linked with the protocol. Okay, so it means that if you see HTTP here, by default, except the cases when you specify it specifically here, for example, 81, it will be using port 80 for all HTTP requests. That's why if I open, let's say, like this, so I have s.protasov.ru. Yeah, this is a website which is insecure. Yes, and I can do the same if I type 80 here. It will lead me to the same website because 80 is a default value for here. Okay, the same will happen for HTTPS. So if you go to Yandex.ru, for it's a secured website, so the default port will be 443. It will lead me to the same page. Okay, it eats the value. Okay. So these are things which are managing. So the point which these together, maybe you heard about what is called the web the socket, like in operating systems. There is this thing called socket. So they together, the machine name and the port, they form a socket. So the place where you can plug your request, so which you can connect to. Then sometimes these kind of machines require authentication. So you should provide your login and password. And there's in URL, there is a mechanism which allows you to do this using user password at. What we already saw, we saw this part, user, column, and at. If server doesn't require authentication, it will just skip this part. That's why we can misuse this functionality to fool a client. So we will provide this some random server name instead of a username. And we will hide password, so nothing, and we will put our domain name here. This can be tricky for a person who clicks the phishing link. As I mentioned, protocol is the way how we communicate with the machine. So the language, it specifies the language of communication. And this part identifies the document in the machine. Previously, lots of years ago, when the Web 1.0 was managed by just simple web servers, the idea was very simple. There's a file system on the machine. And when you retrieve a document, this is the path to a file. So you just add the path in the Linux system to a file, and your web server will what? Will read this document and give it as a content to the user. Later, as I mentioned, the internet became interactive. So the servers started doing some actions before preparing the page. And these actions made it possible to first parameterize the request, give some parameters. And let's say this will be my username, this will be some answer for a question, and the answer will be given with respect to my data. Okay, so I can provide these parameters in request. So the simplest thing is that if you type, Google.com, search, Q, and what do you want to, a cat. I will search for a cat. This is my parameter. And of course, there's not a static thing. This is just a software which reacts on my parameter. So the parameter is Q, the value is cat. And woohoo, cats. So the response was created with respect to my parameters of the URL. If I change them, the answer will be different. This part, the hash is usually called an anchor. It refers to the part of the document. So if there is document separated into some parts, you can use this to address some particular block in the document. The simple place where you can find, for example, if you want to go to for Python docs, let's say URL join method. So let's go here, and if you open some particular subsection, you see it here. Here is the hash and the name of the subsection here. So if you copy this part, open the new tab, you use this with hash, you open, it will scroll down to this part of your document. Okay, so the whole document retrieved by the browser is the same, but for you as a user, it gives additional information and navigation in the document. Okay, and what's left here? Nothing. So except maybe the fact that the protocols can be different. So HTTP, HTTPS, we will cover them slightly later. Web service protocol, which is used for web programming, also can be different. And you see that there are some default ports. So for example, for here I provide 443, means that I will use secure socket layers, but usually we can omit it if protocol says that. I usually use it as a default, just for you to know. Okay, anything important here? Yeah, so just recap, and we will go for a break for 10 minutes. Great. So first, hypertext HTML HTTP. Hypertext is something which links the documents in some semantic network. HTML is the way how the internet creates such documents and manages such document. HTTP is a protocol which transfers this data over TCP. So there's TCP protocol, you remember, one which ensures the integrity of data which you send. HTTP is the one which is created to transfer hypertext data from the server to your browser in a term of integrity and so on. There are some methods which can be used in requesting the documents. For example, get, post, we will speak about them after the break. And there are some headers, meta information, and so on, so on, so on, so on. And also there are some tools which you can use to test your things. This is, of course, your browser. You can use Telnet. We will try it. CURL, wget, and Postman. These are tools which are useful for testing your URLs. And there's also the thing which is called URI, which is an identifier, and URL is a subset of these identifiers, which gives you not only the identity of the document, but also the way how to retrieve the document from the web. Okay, so how to find the content of this document. Great. And after the break, we will continue with HTTP. If there are any questions left about this part, it's exactly the question, the time for questions. Yeah, the question. Why we had to write www before the main names and we don't have today? The question is very simple. Sometimes we have to. I don't know. Let's imagine some website which is not working. Maybe there's something in my cache. The answer is very simple. So I cannot provide you from my brain this particular answer right now. But the question is very simple. www is what? Is a part of the main name. This is again the name of machine. In the previous years, when there was a company, like imagine Google.com, there was a set of machines which are grouped together in Google.com block. Yeah, and before them, there were a set of servers which were responsible for one for mail, other for giving you web documents, other, for example, I don't know, will be SMTP for machine interaction for your mailbox and so on. So there was a set of servers which are named somehow. And when you go to Google, the domain service of Google should address you to a particular machine, which will return you the answer. Today, with today's technologies, the routing can be more smart. So you can put this routing part here, because there will be like a, if you like the simple example, search Yandex was previously the name for a search service of Yandex. What will happen now? Come on, it should work. Okay, search Google.com. Op, it redirects you to Google.com. What does it mean? That of course it remembers that someone used Google for like search Google.com previously, but for now this problem can be solved like this. So if you use Yandex and you want some particular service of Yandex, it will hide here after the slash. And Yandex will be managing routing based on the URL rather than on domain name services, because Yandex wants it to be fast. Yeah, DNS is a slow protocol, and if Yandex knows how to find the machine in the best way, it will, instead of using the predefined domain name infrastructure, it will use its own algorithms to faster find the best machine. Of course, this particular machine, if I even reload the page now, it will every time send a request to different machines. But this is all hidden behind the load balancing software. So previously it was domain name service who managed this. Today, load balancing software is doing the same. So this, again, different machines, but so the way how we manage is different. Any other questions? But others can go for a break if you want to have 10 minutes of break. Will semantic web make the web scraping easier? Actually, in fact, it should. But I would say that there's like the movement from both directions. So it's good when a person creating a new service follows the semantic web approach. It's good for person, because the websites which integrate, for example, OpenOrg, Web Schema, and so on, they are ranked higher in the search engines. So it's for your need to put this markup into your documents. But you can just don't give pay any attention to this. From other side, the creators of software, they understand that people sometimes misbehave. They use these things in the wrong way. So as I mentioned, I was trying to give you an example of the good snippet. And what I found that actually the majority of services which meant to be like marked up in a good way, which should provide the address, the phone number, and so on, they are not giving this information in their websites. So that means that the services which crawl the data should be smarter, and they should retrieve information from the raw content. And this is maybe the topic for other courses in this master program, like data mining or whatever. But yes, if someone follows this approach, you will get better snippets for social networks, for search engines, and so on. Break. Yeah, break. Guys online, how is the sound? Do you like it today?
Yes, it is very clear, very clear.
Great.
And I
Well,
can
good.
hear the offline students too, which is a good thing.
Good investment into the mic. So I'm going to run attendance check. Sorry for this. I have to do this. Muhammad Awais. Okay. Okay. Ayomide.
Yeah, I'm here online.
Okay. Kirill. Yeah. Okay. Edelquin.
I'm here.
Okay. It's so small interface. Denis Fokin. Khadija is here. Roman Garaev. Vaigu. Ikram. Ikram Hamizi.
She's online. She probably went on a break.
Okay. Okay. Firas. Елизавета. Daler.
Here.
Okay. Yaroslav. German. Айдар. И Данил. Данил. The one who is for a break. Данил Дашихин. Do you know him? So not here. He's not present today. Okay. Is there someone who is here but went out? No, everyone is here. Okay. Okay. Absent. Okay. Great.
Hi. You
Hi.
took my name, but I wasn't here for a second.
I cannot see you, but I can hear you. Yeah. So I marked you as present. Okay. Save attendance. Okay, let's speed up. I understood that I have 40 more slides, but you know that my pace is not regular, so maybe I will run faster at some slides, some session information only. Oh no, I dislike it. Google started reloading the documents if it has not enough RAM. Okay, somewhere. Boom, 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 boom. We were here. URL, right? Yeah, HTTP. So great. Presenter view. Okay. As I mentioned, one of the important protocols for internet is HTTP, a protocol which transfers the data with a hypertext or any text or any data originally created for web browsers, of course. So for you to get the data from the service and then to render it and to show it in the browser, but also for any other needs, which can be a communication of two machines. So the idea of this protocol is very simple. So yes, I want to transfer some data from one machine to another. Why just shouldn't I use the raw representation, like, I don't know, the binary format or whatever? Text information allows us to debug the communication. So whenever you want to see what's going on in between two machines, you just display the content of the HTTP packet, HTTP frame, and you are able to see all the options, all the headers, all the parameters, the content itself. So everything which is essential, even the data. If it's represented in HTTP, you just can look at the data and you can see the content. it's very useful for tuning the software, for understanding what's going on. Yes, of course, this is the application level protocol, so it's created for browsers, and originally to deliver text, later any data. It requires like parties to be unequal, so there is a server who serves requests, and there is a client who retrieves the information. So there are two roles always: the one who asks and the one who answers. In the original format, the HTTP version 1 is a very simple protocol. It supported only single request per session. So you create a TCP session between two machines. You make a request, you get a response, the session is closed. Yeah, usually this is not like we are doing with websites. We open the website and then we start interacting with the website. So it would be nice to reuse this session, because TCP requires what is called handshake. So there's a communication of two machines which negotiate on how they will work together. So that means that HTTP was like, it had a big overhead in this communication. And there was only 3 methods which you can use to work with documents. The GET, the one which is actually like implicitly you're using when you retrieve the document in the browser. So you say, I want to get a content from a server. You send a GET request to a server, and it returns you the content of the document. Sometimes, I don't know how it's useful for a human, but machines can use this. There's a head request. The head request is the request which is the same as GET, but it does not download the information. It only, if you go for a document, it can give you what? All meta information about the document. So the encoding of the document, the size of the document, the, I don't know, encryption method, the compression method. So everything except the content of the document itself. It's very useful if you want to, for example, build the progress bar. So when you download the file in the browser, it shows you how much data remains. You first go with a head request, and it shows you, for example, the expected size of the document. Now, downloading each bulk of information, you are aware how many of the whole document you download. So head is a lightweight request. It doesn't require to transfer a lot of data, but it's useful in some technical communication. And there is also, like with appearance of Web 2.0, people understood that if the server is a software, not just a collection of papers, what if we can do something with the server? What if we can send the data to a server rather than obtain the data from a server? So I want to put my personal data. I want to send login and password. I want to send a new picture to the social network. So how can I do this? Of course, I can somehow trick and try to do this via GET request, but GET request is very limited in terms of what it can do. And there is a POST request, which is created specifically for uploading the data to a server, for any changes in the server. So you take the data, you pack it in a specific type of request, and you send this data to a server, and server can accept this data and store it or process it, whatever. Next iteration of the protocol, HTTP 1.1 is actually I think the most popular right now. It's like more than half of all the servers implementing this protocol. It also worked in the direction of understanding that server is not a collection of documents, but a software. For example, there should be a difference between POST and PUT, because POST is like just a general way of uploading the data. If you want to be more specific, you can think in terms of methods, like or functions in programming. If you want to put an object to a server, you send a PUT request. Yeah. Instead, if you want to change a document on a server, you send a patch request. Yeah. So you see the difference. If you want to delete a document, yeah, with some particular identity, you will send a delete request. So these things are kind of specializing the requests for doing different tasks. Altogether, these requests, they are very useful in the paradigm which is called REST. You hear REST API. So it's a way of creating a software which is running through a HTTP request. So Instead, when you write a code in Python, you write functions you call them from libraries. Yeah, you take the library and you use names of these functions to call some functionality. In web, you use URLs to call some functionality of the remote server. Yeah, but not just URLs, but also the methods are important, because the same URL can be doing, for example, let's say, I don't know, Facebook/user is everything about managing a user. If you post a user, you maybe want to create a new user, or if you want to put a user, you put a user. If you want to delete a user, you send to the same URL the request called delete. Yeah, so you're managing the data on the server with a protocol. This is often misused. So sometimes people still limit the functionality of their software by post requests, whereas they have the opportunity to use this variety of requests. And next step is, and this protocol already implemented the multiple requests per session. So you have the session, you open a connection to a server, you send a request for a page, it returns the page, connection still open, you send another, and using the same TCP connection between two machines. So you establish the connection between two machines, and you use this channel while you're working with the server. No additional handshakes. Important. Next iteration is the protocol which is now deploying to the web. It's called HTTP2, or originally it was called SPDY from Google. It's binary, so now it's not for humans. It compresses the headers. We will speak about headers later. It allows server pushes. So it means that if you download the document, it opens TCP connection, and server can, without any notification, send you additional data and additional data. For now, there are WebSockets created for this additional protocol, but it's now implemented like on the level of HTTP2. And also, what's interesting, it can now allow you to multiplex over a single TCP connection. So when you open your web browser, what you do? You create small, like sometimes big set of applications, web browser, because each tab is a separate application. If you open Task Manager, you will see multiple applications running. And each of them is running requests to the website. If you use Wikipedia, if you open 10 tabs of Wikipedia, you create 10 TCP connections to Wikipedia web server. What about gluing them together? Yeah, and this is what HTTP2 suggests. It opens the single TCP connection to a web server, and all these tabs can work through the same TCP connection. Again, reducing overhead. Like TCP session for multiple requests means that you have the open browser window. You send request, server returns you the answer. If you want the next page on the same website, you reuse this connection within the window. If you have multiple windows, you have a single connection shared among those windows. The first question was here. Just a second. Please mark my attendance, Khadija. Khadija, I marked your attendance. The question? How does HTTP save the session? Good question. We're moving towards this. So HTTP stateless protocol. Okay, great. So first, just a short overview how HTTP looks like. So HTTP, as I mentioned, is a full text protocol. It consists of two important lines, some number of not very important lines, and maybe content. So first line, the very important line, is three very important words. First, the method you use, space, the document inside the server, so the last part of the URL you want to retrieve, and the protocol which you prefer to use to communicate with the server. So it can, if it supports, it will return you on the same protocol. Next thing is the host which you're connecting to. Host is here is the host name plus a port. So if you want a particular port, changing this can dramatically change the behavior, because if you establish a connection, I will show you with a website, which a machine which stores two websites, based on this part, you will retrieve different documents. I think I have the example here. I will show it right after. This thing is called the headers, and they store different meta information about you as a client. So you, for example, say that I don't want to accept the cookies. I accept the documents of this type. Please provide me documents of this type. And this can be important if the same URL can serve you, for example, with a PDF, with a WAV file, and so on. So by this information, you can choose which representation of information is preferable for a user. Or, for example, it can say that my browser knows how to uncompress gzipped files. So I send the information that if you can zip this information, I will use less internet traffic. So it's better for me. So please do it because I know how to unpack it back. Okay, so that can be useful information sent in the headers of the HTTP request. HTTP response looks very similar. It returns you these three important words. It says, I answer you in this protocol. Sorry, I don't know 1.1. I will answer in 1.0. 200 is the status code, which we will cover later. So 200 means, okay, nice. Everything went okay. And this is arbitrary text, which can be omitted. So usually it's a textual representation of the code. And it gives you meta information about the document. It says how long is the document, what's the char set of the document, what's the format of the document, how you should represent it, and so on. Then it gives you the space and the content. Here also for request. After a blank line, there comes some content which you would like to post there, for example. Okay. Small example on using Telnet for HTTP protocol. I have this window already open. I will make it smaller. Clear. Okay. So for now, I call Telnet. It's a software which allows me to use TCP as a raw. So I will be using TCP as a raw protocol. First, what should I do? I should establish a connection between my computer and some machine. So how I can do this? And open as Protasov, the true, and I will put the port which I will connect to. So I need a socket, not a machine, but a socket. Okay, 80. So this information is enough. So it's connected. Now I can send requests to this machine in a HTTP protocol. So now this is a TCP session, and I will use the language of HTTP to communicate with the web server. I can say what? I can say head/HTTP 1.1. I will specify the host, and it will wait. So I made the blank line. If I do 2 blank lines, it says that the document is ended. It returned me the text. So yes, HTTP 1.1, 200, okay, and some meta information. So this will be a document. The length of the document will be 7 kilobytes. The char set will be UTF-8, and so on. So last modification was like long ago because I didn't touch my website for a long time. Great. What if I want to retrieve the head of the same machine, but with another website? What if I write head/HTTP 1.1, but instead I will say what? Host code test dot true. So you remember that these are 2 services running on the same machine. So I established a connection to a physical machine somewhere in New York. And now I would do what? I send the different information. And what you see here, it returned me the different status code, which is redirect actually. It returned me the location where I should redirect. Okay, because it says that my session is expired, so I need to log in. Okay, it's login form. The content of the length of the content is different. It's 77 bytes. Yeah, so it's a different document. So based on the request to the same machine, I obtain different documents here. So if I want to get the content, I will write what? Get/, HTTP 1.1 host as protasov.ru. It will print me what? Woof, the whole HTML document. If I do the same, I will retrieve this in the if I press F12, and if I open source, this is exactly the same content. I can see it in the browser. So we now know how browser works. So this is like, yeah, this is the book, the last one, podcast, yeah, the book one, and so on, so on, so on. So the browser actually is doing the things which I already showed you in the console. So this is the same action. Browser uses HTTP request to obtain the information, and then it renders the document. We will speak about rendering right now. Okay, so I hope you understand that this is a very simple protocol. You just type some words and you obtain the documents. This is how the internet is working for the last 50 years. There are some important headers. Like, yeah, the question?
Yes. So if you can please go back to the previous slide.
Previous slide. Okay. Just a second.
So you opened a socket connection to port 80 on this domain. But why are we able to like access the content of another domain?
That's a good question. So why I connected to one domain, but I can retrieve the documents from the other? Very simple. So when you use Telnet, Telnet is TCP protocol. It lays upon the IP level. And what Telnet does, actually, it first sees the host name, and it is confused. It doesn't know anything about host names. So it knows how to go through the internet using IP protocol. So first, Telnet implicitly resolves the name into IP address. Yeah. So this line, this one line, oh, sorry, which is O as protasov.ru 80, is equivalent to what? First call DNS, replace as protasov.ru with IP address, and then connect to this machine. So at the moment when we connected, you remember, I hope I can scroll it back. You see, it says I opened as protasov.ru, but it's trying to connect to IP address. Yeah. So it's actually established a physical connection between two machines. And this is level lower than DNS. DNS works as a separate protocol, and we don't care about this protocol. And now we have a channel between two machines, my physical machine and the physical machine in the data center in New York. And this physical machine resolves the headers. So it gets the textual information, and it makes a decision on which service to call based on this host part of the header. Is it clear?
Yes,
So
I got it. Thank you.
I understand that this is a confusion, that we already explored multiple ways how the same company can provide you multiple services, hiding them. So they can use like this part with www in the beginning. They can hide something in over the slash and do the routing upon this information. Also, they can even work with the content of the requests and resolve, even change the machine based on this. Yeah, so you understand that the variety of things which you can do in web is large. And when you retrieve the documents, you should understand whatever you call can be like whatever URL you retrieve, whatever document you want to download, can be much more sophisticated than just retrieving a file from a machine. Okay, so important headers. These are about representation. So accepting what you accept, which encodings you like, what do you know, the compression mechanisms, important. Authorization, we will go for this right now. So if the web server requires your login and password, maybe you need some credentials to provide. Content length, again, if you request something and you're sending the data, you warn the server in the beginning of the message how much data will come later. Okay, the server should understand how much time it will take to upload the data. User agent, information about your browser. Upgrade, if you, like this is the important for development. This it's actually from development course slide. Upgrade means that if you want to communicate in some other language, not HTTP, but for example, WebSockets, then you say, I want to upgrade my communication schema to this, to WebSockets. And later we will speak in another language. If server accepts this, you can start communicating. Response can also send you different interesting headers, like caching of documents. So saying that the document, for example, will not change for the next 2 days. So if you store the copy on the hard drive, it will be easy to retrieve the document. You don't have to go to the network. You know that for the next 2 days, you can grab it from the hard drive and it will be stored. This is what you did actually in your homework. You cached the documents to the file system. Encodings, languages, and content type provides the browser an opportunity to choose with which method will you visualize the document. If it says it's PDF, it will call the PDF plugin. If it says HTML, it will render as a page. If it says that content language is, for example, English, it will show you the pop-up window saying, do you want to translate this document from English to Russian? Just how it happens in Google Chrome. So this information is important to choose the behavior of the client. We will go to this later, but this screenshot shows what? The browser, this is, you see that the first request of me to some example.com website, which I never saw and which never saw me. And just imagine how many information I send there. I send my user agent. I send my accepted file types, which I can process. A lot of information, not that much, but we'll see that this is actually enormous amount of information. So just the first time I send the request, I send some information about myself, the browser fingerprint. This user agent is very important. It says that what's the actual version of my browser. And you know that browsers are updating very frequently. So the Google Chrome is updating, I don't know, daily. Once there was a cool story about testing the software when I was young and was working as a developer. There was a tester, like QA in our company, who tested my functionality, said that it doesn't work. He came to me and opened in the same browser, the same functionality, it worked. So we came to his machine, it opened the same browser, and then it doesn't work. And it occurred that overnight, the Google Chrome just updated on his machine and didn't update on mine. And they just removed some functionality which supported compatibility with Internet Explorer 6. You remember that there was a browser like in the ancient days of dinosaurs, IE6. And this just happened implicitly because no one warned the person that the browser is updating. And we were trying to catch the problem, and the problem was in the version of the browser. Okay, response codes. Whenever you do a request, the server can say, was it successful or not? There are 5 big groups of requests. This one relates to more technical things like switching the protocols. You remember that you can request to change the protocol of communication, and it can accept it. 200, they are the most beautiful ones because they are success. If everything starts with 200, means that you're okay. So 200 exactly means you asked for a document, here's the document. If you want to create something, it will return 201 saying I created. You did post, I did post. If it returns a partial content, please expect other parts. So 206 means that this is not the full document, but the part. Other beautiful results are 300 something. They are about redirection. So moving you from the, you remember 302, it was moved temporarily. So 301 means you moved permanently. So you come to the document, says now it's here. So as we tried to search Google.com, we went there and the browser with a high chance returned me what? It returned me this kind of response. We can check it. You can open in browser, track the network communication and see that it sent the redirect header saying that now you have to go to another website to get this document. But then after 300, things that go like very bad. There are 2 blocks of codes which the server can return, saying about problems. 400 something means that you are doing something wrong as a client. So if you retrieve a document in a code in a browser and you see 400 something, that's on your side. problem of something. Maybe you didn't provide credentials. Maybe you're trying to access the document which is not present. Multiple things. There are also some specific codes for web servers. For example, for Nginx, there's 444, which is only specific for Nginx. There is 416, is a jokey response called I'm a teapot. So when you send a request to a device, it returns with a status code 416, which means that the device is a teapot. It has some mythology behind, but better read Wikipedia and not spend time on the lecture. And the other thing that there is something wrong on the server side, and something starts from 5. It means that maybe you're doing okay, but server fails. So usually 500 means that there is exception in software, and the document cannot be rendered, and the server just returns this saying that unfortunately software crashed. 503 means there's usually infrastructure problem. For example, you cannot, the web part cannot connect to database, and there is no network connection, so it returns you information about that. Sorry, 5502 means that there is some, again, infrastructural thing that the load balancer which accepted your request cannot find the server, so that there is timeout in searching for someone who will serve your request. So you came for a service, and no one is you call the phone and no one takes the tube. So that unfortunately our service is not working right now. So these codes are important to know. And when you crawl the data, you base your code on these codes, your software on these status codes. If it's 200, that you know that the document you retrieved is okay, that which you could do in your homework. For stateless HTTP and working with software, of course, HTTP is just the media of providing requests. Some of these requests can be safe and not safe for the server. So changing and not changing the state. So safe request means that it does nothing to a server. Server doesn't change. You request the data, you retrieve the data, server status is the same. Head, get, options, trace requests, they are safe. So you do get request and server doesn't change. You just return the information and nothing changed in the database, on the file system, and so on. There are non-safe requests which are changing the state of the server, and they are split into two parts, in the idempotent and non-idempotent. Idempotency is defined like this. So if you do multiple same requests to the server, idempotent means that only first takes action. So for example, if we speak about delete, what does it mean? You want to delete a user. You delete a user once, and after this, sending a delete request changes nothing on the server because there is no such user. Yeah. So this is the behavior which the software should support. If you send a delete request, it should be idempotent. The same for put. If you put a person with identity Stanislav Protasov to a server, if you send again, there should not appear two Stanislav Protasovs on the server. There should be a single one. But for post and patch, it can be. So if you send the same request, it can do multiple posts. So you want to post to a social network, you make a post. Yeah, you post the data, the post appears. You post again, another post appears with the same content. Yeah, so the things are complicated here. So knowing the internals of the HTTP is very important when you crawl the data. How do you parameterize your software which is running remotely? With parameters. There are two ways of providing parameters. The one which we already covered in the URL part. So you can use equal sign to split variable name and the value, and you use ampersand to split these pairs between each other. When you do the post request, you take this part and move it to the body of HTTP request. So after the blank line, you do post, path, you write host, then blank line, and then you put these parameters. There they will be processed in the same way. Sometimes, so you asked about the stateless protocol. Sometimes there is a need to establish some, love story about your server and yourself. Yeah, so you want them to create the common common life. They want to live together. And whenever you return, there is the person who loves you and who remembers you. This is what is done for targeting, for greeting you in when you come to the website, say, hi, Stas, I'm very happy to see you again. And of course, if HTTP is stateless and you provide no information, so how this server will know that you returned back. For this, there's a mechanism of cookies. Mechanism of cookies is very simple. This is the parameters, like the same parameters, which are detached from this mechanism and placed to the hard drive. So your server can send you some parameters, which you will then store. And then whenever you send the request, you will attach them as like an additional patch to the request. They will go in the headers part. So in the header, there will be additional line of parameters which you store on your hard drive specifically for this web server. And the web server says, please store them. And this is where you store your session keys. This is where you store some specific information about your previous communication with the server. And it adds some like additional memory usage, but it's small. And you know that every time you open the new website, for now, it asks you, would you like to use cookies? So for now, you can reject doing this. Previously, it was just a common strategy. No one even asked you about this. Cookies look like this. So you approach the server. The server says, please, this is the response, yeah? Please set the cookies, so the name, value, and the difference is that for this one, please store them eternally. For this, store them until June 2021. Okay, so they can also say how long should you store this information. And then when you send another request to the same service, you send these cookies again and again and again. So this can create a state of your software, but this state is stored in your machine, not in the machine of the service. Nice, I hope. Few words about the fact that HTTP is not the only text protocol. There are other text protocols which are very similar in terms of how they behave. For example, FTP, the same protocol, but for file transferring. It uses by default port 21, 22, I think. The 21, yeah, 21, and 22 for transferring the data. And it is, again, the textual communication between machine and user. So you can use the same telnet to retrieve the documents using FTP protocol. There are email protocols, SMTP, POP3, IMAP, which are, again, very similar. They have this HTTP communication at some ports. These are default port numbers, which make your mail software work, like your Outlook, your, I don't know what you use, Spark, how you call the software at your laptops. So your clients use this protocol to communicate with the mail server. So very similar to HTTP, with like even the names like SMTP, HTTP, transfer protocol. They all work like this. There is IP, there is TCP, which guarantees you the delivery, the integrity, and there are protocols which work. So HTTP is for HTML, FTP for files. These are for sending emails. Okay, and now we move to the most important topic of today's lecture. We have only 40 minutes left. I will try to make it clear and only keep essential things. There are three terms which are oftenly misused. So, and actually they were simple. So it's just once you should understand them and then use them correctly. Identification. There is something which identifies you. I have a passport number. This is my identifier. This is my identity. You can steal my identity and use my identity somewhere. You can steal my passport and take the credit from the bank using my passport, if it's possible. So my identity is my passport number, I don't know, something. Identity says nothing about access. It just gives you the way to attribute you to some other thing. So of course, I don't need anything else except me to live in this world. But services are not like plugging me into a computer. What they can do, they can plug a passport number in the computer. So I will be happy to have only me and no passport. But the world is complicated, so that's why I need identifiers. And you know that we have multiple of them. Emails, we have passport numbers, social security numbers, all this stuff. They are all identities of us. Second is authentication. It's a very simple procedure. You come to a bank with an identity. And there's a person who says, you don't match. Your photo in the passport is not the same as your face. So authentication means that you check the identity with the owner of this identity. You understand that? Yes, so this idea. It means that if you pass this procedure, then you can proceed yourself. So first comes your identity, then the person says, do you match? If you match, then you can continue working with the service. Yeah. In the bank, you come with a passport and you want some money. But if there is no you, what should they do? They put the money in your passport. Yeah. So they will give money to you. Yeah. And the ability to get money comes after authentication. Yeah. So you are correct, Stanislav Protasov, specified in the passport. For this passport number, we have a record of account. On this account, we have some money. So please get your money. And ways of authentication, they are multiple. They consist of identity and some secret. Yeah, usually my like PIN code of bank card. So bank card has a number. It's my identity. I provide a PIN code as a secret. Username and password. Yeah, username is identity. It's public. Password is a secret. Fingerprint, secret. Yeah, so and so on. They can be multi-factor, and you know that it can be very important to have multi-factor identification. So it's a multi-factor, multiple secrets. Password plus SMS, short text message for your smartphone. It can be fingerprint plus password, and so on. So very useful. And authorization is the next step. You're identified by some number. You're also authentified by some third party, by a person in the bank, by software, and so on. And you want some money. I come to the bank, I give my passport. They say, yes, this is Stanislav Protasov, give me $1 billion. Sorry, you're unauthorized to do this. You don't have a right to get this because our software says that you don't have such money. So there's no way. Yeah, we have such money. Like we're a bank, we have $1 billion, but we will not give it to you. So who are you to get this money? You're not the director of the bank. If it was a director, we will give you all the money. Yeah, this is authorization. You should have authority to get something. So it's granting access based on your identities. Your identity defines what you can do, what you cannot do. Okay, 3 things. Wonderful. So for HTTP, all 3 things are important. So you can use it to limit access to some particular documents, for some particular APIs, services, for some particular people, maybe. There is the built-in protocol, which is now mostly not used, which is working through the headers mechanism. So there is the www authenticate header in the request, which you can send and which you can accept from the service. So I went to some service with GET request, and it answered me, you are unauthorized. Sorry, so you're not given a right to get this document. So please provide us basic authentication, so some particular procedure of authentication, and we will let you here the area to be accessed. Okay, and then I can do what? I can create my request and send the header like this: authorization, basic. So I said yes, it's basic, and I prepare my login and password in the following form. So this is what is not that common today, but it's still used in some services. When you send your login and password, base64 encoded, and just attach it to a header. Of course, it's very insecure if you send it without any encryption. Yeah, so just HTTP is a plain text. You plug, I have a cord. Imagine this is a cord, or you have a radio. You sniff the traffic. You grab all textual data from the traffic. HTTP is like plain text. You just grab this. You base64 it back. So you decode it, and you know my login and password from the service. Not that good. That's why no way of using it without HTTPS. Yeah. So HTTPS, we'll cover it later. And also, there was another way of doing this, is more sophisticated thing, which had a negotiation with some digests, with some MD5 hashes, which actually was an update. So it's a digest authentication. It's an update which allowed you to hide your login and password in this communication. And this was based on the cryptography, saying that it's very hard to reverse back your credentials from these functions. But it actually doesn't protect the data. If still you can sniff the traffic, you can obtain all the documents which are sent in both ways. And another way of authentication is what is standard de facto right now. It's called OAuth, and this is a new concept. So previously, I was speaking about the client as what? As the person sitting behind the computer. Yeah. So the person wants to get a service. Person provides identity, provides a password, and gets the document. OAuth brings another party in this, saying that you usually use what? Your smartphone to access the service. And to do this, you do what? You use software. You use browser, you use clients like Twitter, Instagram, and so on, so on, so on, so on, so on. And you can use both. Moreover, you can use multiple different softwares to access the same service. Yeah. And to do this, we can follow the procedure. We are granting access not to a user, but to a particular software where the user is logged in. This allows you to manage it in two phases. First, you can manage a user and say that you allow or disallow this user to do something. But also you can manage a software. Both, you can manage a software of particular user and in general. Imagine there is the application in, I don't know, in Twitter, which is an official client. And it, for some reason, it was in a Google Play Store. Yeah. And in like few months, security engineers understood that this software was actually what? Bitcoin mining software. So your smartphones were actually used to mine Bitcoins on someone's profit. Yeah, it sometimes happens in web. You open the website and it starts mining Bitcoins in your browser. It computes some software in your browser. And what they can do? They can ban using this particular client for everyone. But they doesn't ban you personally. Yeah, they ban the software. Software stops working. Then you do what? You see that software isn't working. You delete the application and you install the official client. This is how it works. For example, this is the more flexible way of managing both software and users. And the flow is very simple. So here is me using a client software. Yeah. So for simplicity, it will be Instagram client. So for simplicity, I say that Instagram client uses HTTP protocol to communicate between server and the software. So they communicate. Sorry, like this. So this is the user using software. Software communicates with the Facebook data center. Yeah. So this is HTTP working here. When I want to use Instagram, I go to a third-party authentication server. It can be a part of the infrastructure of Facebook, or it can be external thing. So sometimes you remember you want to log to the website, for example, Overleaf. You use Overleaf for LaTeX text data, and it allows you to log in with Google. It says, I will use Google to authorize you to use this software. So you go for Google. Google says, yeah, this is you. You can use it, and it issues your software a token. So you go here with your credentials, login and password from Google. Google issues a token to a software which you want to use. And this is like a string of hexadecimal numbers. And this token is used to communicate with the server. And this token, as you understand, stores information both about the user and about the software. And the service asks an authentication service whether this software is allowed to access, whether this user is allowed to access, and manages access based on this information, both on the roles of a person and the abilities of software. Yeah? For example, if you ever used Moodle client in your smartphone, you could see that, for example, Moodle client, the software itself, has a limited possibilities compared to the web version. And if you try to do something illegal from the Moodle client, maybe this is not the official Moodle client, where someone is trying to fake the identity of software, and then you should block this particular instance. So OAuth, again, so there's the an authority which is sometimes outer, sometimes internal to the service, which helps the service to manage these two stages of filtering, both a human being and a software, which can be switched off separately. Okay, great. To the ancient days, this is what you all know, the form authentication. Forms means that you use all previous things, all previous protocols were integrated into the HTTP as headers. So whatever you do in OAuth, you do in headers. So this is all in meta information of your communication. Forms authentication moves into a content. So this way of authentifying a user is based on a software. So instead of using some pre-built tools, majority of websites, for example, I don't know, let's say, it's not a good example because it's my service, but code test. You go here, you press F12, and you see that writing login and password here is going into what? There's form, yeah? Some HTML code, which wants me to do what? To insert the login in a textual form, yeah? And insert the password in a hidden form. So that's why it's covered with stars, yeah? That's it. So this all is then managed by a software. So this is not a standard way of authentication. So it's not the web server who manages it, but it's a software which you create. So this is more about development. So it's the next part. These things will fall into the body of the post request to the server, and then it will be processed by the software. And now we move to the next part. So everything what we spoke about, I spoke about before, was related to securing the access. Yeah. So can you or cannot you get the document? But as I mentioned, if you take an Ethernet cable or if you take the radio and switch it on here, you can listen to the Wi-Fi connections. You can listen to raw data from the Telnet cable, and you can store the information still, even without knowing the identity. There are like special extenders for Ethernet cables. You can just plug it inside and listen to all the traffic with Wireshark. That's why we need somehow to protect ourselves in unprotected environment. Yeah, and for this, there exists a thing which is called HTTP Secure, HTTPS. This is not a separate protocol. This is the thing which falls out of the, maybe you know about ISO 7 levels of network protocols, starting from physical level up to application levels, 7 layers of this. HTTPS is not the part of this, so it's very hard to find the place for it in the in this hierarchy, because it's definitely upon TCP. So it's more 4 something, 4+, but it is transparent for other protocols. So it's not considered by higher level protocols because it works transparently. So the idea is here based on asymmetric cryptography and symmetric encoding. What means what? So the server, if you know about asymmetric encoding, has the public and private key, and it can use it to encode information. And the first stage of HTTPS communication is a handshake. So they, client and the server, they negotiate on the common shared encryption key. Okay, so they use asymmetric cryptography to negotiate on the same encryption key, and no one except them will know this key because they use both private information to do this. So you remember that asymmetric cryptography allows what? If a server signs something, like encrypts something with a public key, you can not decode it. But if you encode something with the public server's key and send back to the server can decode it, and only server can do this. So if I don't know the private key of the server, I encrypt my data with the public key, I cannot decrypt it back, but the server can. And when I send it, I'm totally sure that no one can except the server. So this stage is very important to send the shared key of encryption. You generate a key, you send it to a server, you both know this key. Now you can use it because only two parties know this key. And you symmetrically encrypt the data with this key. This is the handshake schema. You see it's very complicated. And here is like encrypted pre-master secret. So this is the place where you send the symmetric cryptography key from one server to another. And after this, you start sending the data transparently for other protocols. How do we store the keys? The container for the key is a digital certificate. This is an electronic document which can be compared to your passport. The task of a certificate is to ensure that the public key belongs to whoever shows this. So it's like showing a passport. If I go here, let's say, I don't know, Mail.ru, because I don't have an email here. So I can click here. It shows certificate. It shows it's valid. And I can see some information about this certificate. So it shows the use of the certificate. So why, what's the reason to use the certificate? So it's used for encrypting the communication between two parties. There can be different needs. So they can be, for example, for signing documents, for providing electronic signature. So the uses of this certificate can be different. So it's like a type of a document. It's a passport. Yeah. It says that it is issued to Mail.ru. Okay. And it said who issued this. And if you go here, you will see what is called the path of certification. And it looks like very similar to how it works in Russia, maybe in other countries. You're given a passport, and in the passport, there is a string saying that this passport is issued by this authority. Okay? And you can go to this authority and ask whether like this passport was actually issued by them. They store this information. And then you say that, why? I get to this office building, which claims to be an official authority of issuing passports. But who gave them responsibility to issue passports? And they say, this is actually the government of Russian Federation. And you can go to the government and say, do you know this? In Voronezh, on this street, there's a building. They issue passports. So, yeah, definitely. This is the right place to get the passport. But if they say no, this can be a tricky thing. So I don't know how to show you the incorrect situation. So maybe I will now find that there was a website who used. Oh yeah, they renewed the certificate, but previously it was not secure. Maybe TV Eurosport.com. Why I kept this? I don't know. Oh, it's redirected. So Again, valid certificate, the same use, another path of certification, other services, but still everything goes to somewhere to the top. So there are some number of top-level authorities, like the governments of countries, which are stored in your operating system. They are pre-installed in your Windows, Linux, or wherever. And every time you check this authority path, you should reach the one certificate which is referred to trusted issuer on the scale of your operating system. Sometimes if you work in a corporation, like in a big company, they issue their own certificates, which are then manually installed in your machines and which make it also transparent. So for internal servers, you use another certification paths, which cannot work for others. That sometimes happen. So certificates are the containers, and they are very important in communication. So they have multiple interesting properties, like the time which they are issued for. So for example, they can be outdated. So the certificate can be valid, but it was issued for 10 years, and then in 10 years, everything stops working. And you can see what? You can see that the next day after the time finishes, your code, which was doing requests to the service, stopped working, because your software sees the certificate became invalid and stops receiving the information. So you need to either pay respect to this and do not use the data, or, for example, add some tricks to your software, which says that even in this case, please give me the document. So, of course, the owner of the service should manage this, but usually this is a tricky thing. You buy a certificate for 10 years and you forget about this. And I'm a professional for like 15 plus years. And I faced this situation multiple times when a company didn't pay attention to the certificate and something went wrong internally or externally. For example, there is a software which the doctors use, the rentgenologists, the database which they use. And it was a lag of 1 day when the certificate was not working. And they were all like upset because what they did, they opened the website and they found that actually the connection is insecure and browser doesn't show the software. They don't understand why, but the page of Google looks like, your connection is insecure, panic. And they just stopped working for a day, like all Russian rentgenologists, they could not do their job just because of a certificate which was outdated. Okay, to sum up, the things which you will go through in your lab, and maybe will help you to deal with this in practice. HTTP has the protocols which support your authentication from the box, like the digest and basic. There is another protocol which is additional, which is built on top of HTTP, which uses additional headers, which is called OAuth, and which is a widely used protocol, which allows you to manage devices separately, like software separately and users separately, which is more flexible for software. At this moment, data is still plain text and transferred, even if you're authorized, transferred in a plain text manner. To support this, you can use the thing which is called SSL, or now it's TLS, to secure channel over TCP. And what happens? It will only change the schema in the beginning of your document. It will become HTTPS instead of HTTP. But when you use HTTPS, it now means what? It means that you are secured in terms of communication. Yes, this is only the reason of encryption. And sometimes in this corner, there can appear that certificate is invalid, meaning that yes, your encryption is established, but the party which you're communicating to is not actually one which the certificate was issued. Yeah. So if there will be a word invalid, means that there is the encryption between two parties, but you went to Google.com and the machine on that side is actually not Google.com. The certificates, they solve multiple tasks in the same way. They first allow you to encrypt the communication with these public and private keys, but also they allow you to know that the party which you're communicating to is the one which owns the valid document. There are two reasons of like major reasons of why it should be. First, you're behaving like the party is behaving correctly, but it's not doing all necessary steps. So for example, certificate outdated. So 10 years passed. So why it's important? The encryption protocols, they evolve. Security evolves. Even if you issue a protocol, a certificate 10 years ago, today maybe the encryption protocols, they are not like trustful. So the hackers can hack them because they are weak. Yeah, and that's why you need to get a certificate with better encryption, for example. Second, you can not pay attention to being authorized by someone. This is called self-signed certificates. So you issue a certificate by yourself. You print the passport on the printer, on the grayscale printer, and you show everyone that I'm Stanislav Protasov. But actually, like, who authorized you to do this? Yes, for now, encryption works, but who you are, where you came from, who authorized you to have this? Maybe it's for the good reason, but self-signed certificates, they are like, again, not a trusted way of communication. And the third thing, that if they are addressing their own identity, that happened, for example, to Kazakhstan. If you remember that a few years ago, it was the situation when the country wanted to install, someone mentioned man in the middle, like for all the connections. They wanted all the traffic go through government services. But if you want to go and use Google.com from your machine, and there is the state server in the middle, what can happen? They can only transfer the data over HTTPS. Yeah, definitely. And they cannot decrypt it because it's encrypted. So what they needed, they wanted to decrypt your data and encrypt it back. Okay, but they don't know the private key of Google. That's normal. Yeah, they don't have it. So what they can do, they can encrypt it with their own key. Yeah, and of course, none of the organizations in the world will issue Kazakhstan the certificate which is signed by VeriSign or GlobalSign, which is issued to Google.com, and the private key is belonging to government of Kazakhstan. And like what government said, it requested all the users in the web in the country to install a new authority in their own browsers and operating systems, which was to ensure that this new certificate, which they own, is actually a good one, to make the software work, browsers work, and so on, so on, so on. But like, you know, that means that you allow Kazakhstan government to decrypt your traffic when you communicate with Google. So actually, this initiative was not that successful. 10 minutes. Let's go. Bye. Why are you doing this? Second time. Is it an excuse? The content of the document, which you already maybe tried. Again, languages, you remember, SGML was the parent for both XML and HTML, and now we have HTML documents which are parsable by XML parsers. Beautiful Soap, which you tried, is one of such parsers, which is used in Python. If you want to read about this, schema documents, which can manage the value of tags, but this is more about machine readability. So we're speaking about documents now. These are schemas. So they are defining the meaning of tags in these documents. Again, we will skip this. Examples of schemas and types of parsers. So very important. The documents, any document, HTML or XML document, can be understood as a tree of tags. So tags are nested. There is a tag, includes tags, include tag, and so on. And this is a tree of tags. And there are two ways of what is called parsing the document. So reading by a machine the content of the document. One is called SAX, Simple API for XML. There are two ways, push and pull, which based on the fact that you just go through the document line by line. You see the tag, you say, new tag appeared, new content appeared, new tag closed, new tag closed, new tag appeared. And these events just are processed by your software. So if you have a plain document, so one level tree, for example, only first level nodes in your tree, then you can use this approach to read the configuration of the file. This approach is very good because it's good for small memory systems. For embedded systems, if you want to put this in Arduino, you can store the XML file in Arduino and read it, and it will be enough memory to process such a file. On the other hand, you don't know anything about the structure of the document. You only know that the tags appear or disappear. The other approach is document object model. So this is actually building a tree. Yeah. So you take the document and in memory you build this data structure, a tree. So the copy of your document, which requires downloading the document in the full. So you have the full document. You map all the nodes to the memory. This is used in browsers, and it was previously very dangerous because it requires unpredictable memory usage. You see how today's applications, today's like, I don't know, Google Documents, for example, steals your RAM enormously. To render a document, you need gigabytes of RAM. And that's the reason of DOM. So DOM, document object model, is actually the full representation of the document in some object-oriented manner. So there are objects, methods you can call for these objects. And previously there was a technique called XML bombs, which were exploiting this. So there was a recursive methods of defining the meaning of tags, which at the moment when you create the tree said that this tag should be understood as this subtree. And this subtree was recursively defined. And when you try to open the document in the browser, it just got all your RAM, just as a fork bomb. So when you fork RAM, and it just eats everything until your RAM is over. It was a way of attacking the servers. And also DOM, as the structured representation, allows you to structurally access the data. So there are selectors, different languages, which can help you to search through the document in some manner similar to SQL. So you know SQL. So you can query the table, and here you can query the document. Browser engines. So how do we see the document displayed by a browser? So you saw that the originals is just a plain text. Browser engine consists of these 4 steps. So it parses the HTML document to construct a DOM tree. Then it renders the layout, and then it shows layout in the browser. There's a good article which shows how, like in details, how they work. You see that this slide was created in 2015, and there are a lot of things which disappeared that time. You see that now even Microsoft moved to Chromium engine. So the number of different renderers for web, it's shrinking. So only Chrome and Firefox actually survived. And there is important 2 things about the engine, that any browser consists of 2 major things. First, you want to display a document. Yeah, so you take the HTML file and you render it in the browser window. That's perfect. But for current applications, for current interactivity, also you need to be able to interact with the document without sending data to a server. And JavaScript comes here. So you need a programming language which can create the interaction between user and web browser without using the server. And that's why you need also a JavaScript engine here. So it's the additional software which allows you to work with the elements of DOM in an interactive manner, to, I don't know, create and remove things, to type something and it will appear in some other places in the document. Again, so just know that there are some things called engines. They are doing 2 things. They render HTML as a picture, and they allow you with the JavaScript engines interact with this. This is how HTML document looks like. I hope you also saw it. There are major tags, styles, selectors for CSS to apply styles for the document globally. And now we move to the thing which is important in terms of security and crowding, about fingerprinting. 4 minutes. This is the website which I approached not for the first time. And you remember I showed you the slide with the first time approach website. And now you see how much data in cookies here. You don't see the values, but the idea that there are a few lines of code, some data I send to the server from my machine every time I access. So browser stores lots of information about me, about my previous communication, and the information which the other party knows about me is enormous. There's a project called Fingerprint.js, which is used by like great variety of companies, like 70% of biggest companies use this. And they say that we can identify a person without logging into a machine, like log into a service, so without providing credentials. So you just open the website and they can identify a person with 99.5 accuracy. And they base this on your meta information of your browser. User agent is different for people. I use this version of Chrome browser, you use another. The language which is set up for me, the default is Russian, for example, for me, identifies me as Russian. The date and time zone, definitely. So they know my time zone. So I live in +3 time zone that limits the world significantly. Support of features, size of my screen, which is sent to the server. Do not track flags. It's very important. So if you want to hide yourself from others and not to send all this information, you put a do not track flag. And this is not a feature to a person who uses do not track flag. There are some things about CPU class, your platform of your operating system, installed extensions to the browser, which also can be obtained by the client page. Yeah. It was Russian, meaning that if you don't want to be tracked, you put a flag that you don't want to be tracked, and they use it to track you. It's a strange behavior. That's why. Different things related to rendering in the document. So if you use different graphical tools like canvases, WebGL, they are used by like servers to assess your machine and collect everything which can be important for identification. Just a simple idea that 8 billion people need only 33 binary features, which split them into halves to identify a person. You understand that only 33 bits of information is enough to identify a person in the world. Yeah, so they collect much more. Of course, these features are not binary. These features maybe not that cool, but the amount of information which you should provide to identify yourself is 33 bits. And that's enough to find you by your browser. Yeah, so the device which you're using right now. And sorry for this, I will take maybe 5 more minutes of time about until 20. Oh, 11 minutes. Yeah, so things which you can face doing crawling of documents in internet. So just to remind you, we are here at the point when the same service can share different domain names. There can be different IPs. There's some services which require authentication, and some services which require encryption. And these are all obstacles for just retrieving documents. You need to encounter this when you download something. It will be a code saying that you need to use HTTPS instead of HTTP. There is a code which says that you need to provide credentials, or auth, whatever. And now even more. Okay, what can be problems when you crawl the web to obtain the data? First, this is the part of your homework. If I run this code at my Linux machine, I know, can I? Oh, so can I get this or not? Let me try. Oh, where's Bash? Bash. Come on, my machine is stuck. Yeah. So let's stop TCP. Oh, unfortunately, it's closed. So I will run this, or you can try it in your machines. We get -O, so I will store it in the document called doc.txt. So I'm downloading some file from web. HTTP tiny CC 00 DHKZ. So it will store the document. Oh, what's wrong? Oh, yeah. So you want me to be a super user to store the system32? No, I will switch to some other folder. Yeah, now I downloaded the file, and this is the document which is returned by a server when I request a presentation from this course. So it stored it to some file, doc.txt, and now I want to cat, so print it out and filter. I wanted to know about quad trees. So I do what? I print the document, doc.txt. I strip new lines globally, and I want to grab everything related to quad trees, quad tree search. So what I expect that there's HTML document which stores this text and allows me to see the whole slide and everything around which text there. Space after what? Oh, I forgot it. Sorry. Oh, sorry. I didn't see the. Ow! That's why I wanted to copy the code and I failed. Yeah, like this. Not like this. Yeah. Additional slash. Please don't kill me.
After S. Yeah.
After S, yeah. Great. Now, yeah, what I wanted to show that instead of seeing an HTML, like the text of my slide, I see some strange thing here, which is actually what? A script. It's a part of code. And this part of code, there is some array which stores numbers, some identifiers, null, 0, and my text. So where am I? It's not the slide of my document. It's the data, which is used for what? For rendering a document in the browser by a browser with not a layout engine, but with JavaScript engine. If like, for major services today, if you open Facebook, VK, whatever, you will find the following. There's a small document, which is more or less similar for everyone, with some JavaScript code. And this JavaScript code starts downloading additional data for your feed, some new posts, some new content. And if we speak about Google Documents, it starts doing what? It starts rendering you the software, because today, like the browser is not just a way of expressing the documents as a picture. Today, browser is the environment for creating software. So what is actually Google Documents? Google Documents is a software written in JavaScript running in your browser. Yeah, so you can do multiple things there. You can create documents, edit them, and so on. It always synchronizes with the server, but the main functionality is in your browser, because this is a very hard software. Google doesn't want to run your code on its side. It wants you to run your code. That's why you download a lot of code, you run it, and to render the document, you render it with JavaScript, and everything is running in JavaScript. And to obtain actually the document you see in the browser, it's not enough to download the original HTML. You also have to run JavaScript. And this cannot be done with HTTP protocol. You need to go further. And this it was a link, okay. And this is the video, which, come on, which you can watch at home, and which shows how it looks like in terms of DOM, document object model. I open this website and there will be lines highlighting here. So you see the bluish things. Just at this moment, new tags appear in the DOM model. So it loaded the simple document, and now just I'm waiting for the document to be loaded, and the new blocks appear here in the tree in dynamic mode. So after I download the document, they are created by JavaScript. The tree is expanded. The memory is consumed by Google, like in this manner. Okay, and to being able to work with such documents, to being able to retrieve the content of such document, which is rendered by JavaScript, you need what? A browser engine plus JavaScript in your software. So if you want to crawl the data, you need this software to be managed from your Python code. And for this, there is a thing called headless browser, the browser with no interface. Major browsers like Chrome and Firefox, they provide this opportunity. There's a mode of a browser which allows you to do this. There's a driver software which allows you to manage the browser, so to send commands, not through the interface of a browser, because there is no interface anymore, but through some calls. So there is a binary driver which you can download for each of the browsers. And then there is a software which automates this. So it wraps the driver and allows you to access the browser from your code. The most famous is Selenium, which you will try at your lab. And there's Puppeteer, which is another way of running, like rendering of the documents with HTML and JavaScript without actually opening a browser, but doing it from your code. Second, you are imagine you are software engineers, not you, but there are software engineers in university. And if you want to download some information, you do what? You import requests library and you parse the content of the document. This is what usually people do. But you should know that any big company in the world knows that you parse the data. So it will be silly to think that Wikipedia doesn't know that everyone, like lots of people download Wikipedia pages for their own needs, because like Wikipedia is a great source of information. Yeah, and of course, you parse the data. That's why they do what? They, instead of like doing silly things with beautiful soap, they provide you APIs. They say that there are like URLs which you can use and get the data in a structured way. Whatever you need. Just headers, perfectly. Just abstracts, perfectly. Names, perfectly. Persons, perfectly. So please use API. And then, like you see that for like 5 or 4 major websites like used in Russia, Wikipedia, Wiki, Yandex, Google, they all have APIs which you can access. Because they want to minimize the harm. They don't want their servers to render HTMLs, and then you will parse these HTMLs and get the information from them. They can give you information for free. Yeah, so please don't use it. Yes, and here are restrictions. I was downloading something, but it stopped working. Now, all these companies consider their data as their competitive advantage. That's their property. And if you can just download the Wikipedia and store it at your site, then you have the same advantage. You have the same data. You can run your own service on this data. That's not fair from the point of view of Wikipedia. And what they do, they protect themselves from grabbing. They want you to allow to follow some rules. And if you go for API of Yandex, there is an allowed rate of requests. So with this rate, you cannot download Yandex in some meaningful time. But you can use this as like the source of information. If someone wants the data from Yandex, you use Yandex. For Wikipedia, there is no such limitation, but there is an etiquette file which says that you should do this. Please don't do this. If you want multiple documents downloaded, please separate them with a vertical line, and they will be collected in the same result. Not to serve 3 requests, but to serve 1 request. So there's an etiquette file. Of course, some companies limit access with access keys, and they control the speed of grabbing. So anyone who gives you access key for free will control the speed. Anyone who doesn't control the speed will do it for money. So they will give like Yandex Cloud, any service which you can get the access token, they will give it for money. So they say that 4,000 rubles per year or whatever. And that's why they enforce you to obey. If there is a free service, they will do what? They will restrict your IP. If you do download, I faced this multiple times. So people were scraping Asos, Wildberries, and other web shops, and they just closed the IP addresses from which the requests came. And also browser fingerprints can be blocked. So the particular person. Also, the fourth one, sorry, 2 minutes more. There are two files which can be present in the web server, which manages your access to documents. Which, if you're a person who are not doing bad things, you want to obey the rules of the service which you're trying to index, for example, to download. And there's a file called robots.txt, whose major task is to prohibit. So, for example, if you go here and we see robots.txt, it says that I disallow you to index these addresses, starting with club search. Why? Because this is a software, and if you get there will be like any link will result in running additional code on the server. I don't want your robot to send me requests which will lead to processing search requests on my side. So please don't go there. So there's nothing for you for indexing, because this is software, not just the document, and so on, so on, so on. So some things which are disallowed to be indexed. It doesn't mean that you cannot. You can, because this is not like the managed somehow. But this is a kind request for robots, because it's robots.txt, file for robots, that you please don't do this. Yeah. And for example, if you see Wikipedia in this file, they say that in wget, there is the recursive mode which is used, and people sometimes use it. And they specifically said that for wget, we disallow to index everything. Yeah, so please don't crawl Wikipedia with wget software. The other thing which allows is sitemap file. So if you go for sitemap XML at some websites, you will find what? Oh, sorry, I think it's just an outdated link. But what about, it's a Wikipedia page, and this one should work, no? Yeah, so it shows the content. So it's like Yandex Video page. It shows where you can go for additional. So it can be one file, but it can be multiple files. Wow, Yandex broke. Let me think. It may be q/ sitemap XML. No way. Okay, so they changed something since last year. Okay, but trust me, I will send you the correct links in the chat. That the idea of these files is to list you, white list you the pages of the website, instead of you doing some random search by a crawler. It provides you the list of all the pages of the service, saying, please download this. This is the list of the documents. Please don't overload our server with unneeded requests. Download these documents, and you will be glad, because this is everything. And for example, I participated in creation of a software which rolled out these files in a weekly manner for a server. So we updated in one of the services these files weekly, so it was pretty fresh for everyone who wanted to crawl the service. So this can be another limitation of crawling. Please crawl safe. Don't make yourself blocked by IP or fingerprint of your browser. If any questions remain, you can approach me today at the lab, in the office, whenever. Write me email, write to Nastya. We will help you to deal with your labs. And if you don't understand anything, I will try to answer your questions if you share. Okay? Perfect. Online, guys, everything okay?
Yes.
I understand you're overloaded with information, but maybe lab will make everything clear. Okay, see you.
Yeah, a lot of information. Thank you.
Okay.